What's going on, everyone, and welcome back to the channel. If you haven't already, go check out the Weld app. We've got tons of content and resources in there that you won't find anywhere else. My name's Austin Hargett, and we are here at the Abacore Benzel and Thermacut manufacturing facility where they create all types of goodies for the welding community. Consumables, MIG guns, fume extraction systems for robotics, all sorts of stuff. They invited us here today to check out their plasma cutter by Thermacut, the Trafire 105 HD. All right, now that we made it back here to Abacore Benzel's R&D lab, I see you guys peeping at this nice piece of equipment here, the Trafire 105 HD. It's a powerhouse of a plasma cutter. But before we get into this machine, let's talk more about what even is plasma. Now, engineers kind of figured out if they took a TIG welding arc and pushed it through a constricting orifice and punched a bunch of ionized gases through that orifice between the heat and pressure, they were able to create the fourth state of matter in our beautiful world, which is plasma. Naturally formed, you'll find that in lightning. So you can say that you're riding the lightning with every trigger pull. Due to the high heat, the electrons peel back from the nuclei, and once the negatively charged electrons spin around and collide into the positively charged ions and electrons, you form plasma. Now, even on a more serious note, guys, plasma cutting does provide tons of advantages in our industry for cutting materials. That arc is over 40,000 degrees Fahrenheit, and it doesn't rely on over-oxidizing a material like oxyfuel does, where we can only really cut ferrous metals, which means steels and steel alloys. Plasma cutting, we're able to cut through any type of metal, non-ferrous or ferrous, and what's really nice and a big advantage, no preheat is required. So let's actually get into this Trafire 105. Now, before we get to ripping and tearing on some different metals, we got to learn a little bit about the machine itself. Your first step, you got to read the manual. Now, plasma cutters are fairly simple pieces of equipment. You need a couple components. You need your work lead, you need your plasma torch with all your consumables, and you need power and air. So although the one biggest disadvantage to a plasma cutter is its lack of portability because you're needing air and a power source compared to oxyfuel where you just need some bottles. However, this thing's got the beans, man. We go through the front screen here. One, I really like this machine and its sleekness. It's got a really cool color to it, as well as having this nice display over here, and they try to make it as simple as possible for us to kind of navigate it. So we can go through a couple settings just on this first screen. There's only one button on here, so you really can't get too far away. Give it a turn here, press it one good time, and now your switch is active and you can change your amperage. This machine is capable of running anywhere from 20 amps to 105 amps, and its duty cycle is actually 100% at 105 amps. So this sucker can straight up outrun you any day of the week. A couple of the other features on here, if we move off our amperage, is we can actually change the mode. So we can be cutting through solid material, or if we have some sort of perforated material or a grid material, we can set that machine up for that. And we have it to where we can even trace it, a trace mode and a gouge mode. So if we need to gouge out welds or we need to put a pattern, almost like an engraving on any type of steel, we can set our settings right and our air pressure right over here as far as the bar or PSI. And as we change our modes, we can change our pressure, change our consumables to do these different types of applications. Let's take a look at these leads, how they're plugged in, and how the consumables go in the torch. Getting your plasma cutter set up to cut is pretty simple. It's got to be DC electrode negative. So that means our torch needs to be plugged into the negative terminal. Well, they've made it to where you're not going to mess that up. You're not going to get it reversed or at all. We've got our work lead that's going to only plug into this right side, and then our plasma cutter torch is only going to be able to plug into this left side, and it's locked in. It's got this nice little fancy keyway where we can pull it up, pull it out, and this little keyway here, the sucker's in there nice and tight to make sure that your torch never comes undone from your machine. So now that we got these all hooked up, let's take a look at the business end of this torch. One thing I really like about this torch is the shape of it. It seems to be pretty ergonomic. I like that the trigger guard on here isn't flopped over where it's hard to pull up. You can really get underneath that trigger guard and get your finger on there easily. Now, it's a little bit more tricky than setting up for oxyfuel cutting. We've got a few more things as far as consumables that go into this torch, so we're going to talk about those real quick. The first thing I like to put in is the old swirl ring here. And what that does is it takes the ionized gas and it puts it in a counterclockwise direction to swirl it towards the orifice of the nozzle. And what that's going to do is help provide that nice cone-shaped arc that we need for plasma cutting. So if you know that you're cutting in a circle, you actually want to cut in the opposite direction that the swirl ring is swirling. So you cut clockwise because the swirl rings swirl in that arc counterclockwise. Something you may or not know, but it helps your cut quality down the road. This little swirl ring here only really goes in one direction, so you know if you put it in right or wrong. And you'll know also the machine will give you an error code if you start putting in any of these consumables in wrong. And this is our electrode. You want to make sure that you're using the proper electrode for the amperage you're running. We're going to be pretty much chasing 105 today, so we're using 105 amp consumables. So we're going to put that in there. You'll notice it's got a nice little spring to it. That's normal for the torch. And then we'll put our nozzle on here as well. So that's where it's going to be constricting all that gas into one tight spot for us. All right, now we got all these consumables in here, but they're all loosey-goosey. So we need to have this retention cap. And what that's going to do is hold everything nice and snug and in place. Now our next problem is our nozzle is exposed. We don't want to drag this across our work. If it starts to go out, we need to replace it. So one thing that we do is we have this shield that screws right over the top of it. You'll notice it doesn't make any contact with that nozzle on the inside. It also has these grooves in here so that whenever you're sliding it, because it is a drag tip across material, it has a place for it to go. Now Thermacut, they sell all these consumables. You can buy all of this stuff separate. There's no longer a need to worry about the cartridges. You'll know that if one piece goes out, then you can replace it with their consumable kit. So we're not running the cartridges here, which I think saves a little bit of money, especially whenever you're only running out of an electrode or a nozzle. You don't have to replace the whole thing, where some companies are moving to that cartridge style. So now that we've learned more about the torch, we're going to get to the back end of this machine and talk a little bit more about the gas and the cool feature that it has on the back side here. Now that we've seen what the business is in the front, let's check out the party in the back. We've got a nice thick work lead here. It's got a high duty cycle, so you need something beefy. It's got your standard connection for your compressed air or whatever gas you're trying to run, or on and off switch, all pretty standard with most plasma cutters. But what you may see here is that we're CNC capable, ready to roll right off the jump with this machine to plug in right into your CNC equipment. We also have what my favorite thing is the self-draining water trap. Now that's crazy, that's impressive right there. The ability to have this water trap on board that's able to be self-draining. If you know anything about compressed air, running water through your lines, through your machine, to your consumables will ruin the lifespan of them. So this is a really cool feature of this machine to keep your plasma cutter nice and dry. So now that we know more about plasma and the plasma cutter, let's rip some freaking sheet metal. And before we can get to going, we gotta talk safety. With any hot work process, you're going to need to follow some safety procedures. You're going to want to have your standard boots, your jeans, your welding shirt, your welding cap, so you don't catch a burn. We're going to be throwing sparks 40 feet away. Not only sparks, but this thing puts out a ton of smoke. Whether you're cutting carbon steel, and especially stainless steel, you're going to want some form of respirator. Now this could be in the form of an actual respirator, working outdoors with a fan, or just having some sort of overhead ventilation. You're going to want it, otherwise you're going to be having tons of black boogers. So the other thing is you want some gloves with some solid dexterity. These Cayman 1540s are going to be perfect for me for what we're going to be cutting on today, anywhere from sheet metal to really thick aluminum. The other thing that we've got to be kind of cautious of is the actual arc. How bright is it? What kind of shade do I need when operating a plasma cutter? Now if you're working at the lower amperages, 20 to 40 amps, you can probably get squared away with a set of cutting goggles. But you get up to some higher amperages, especially what we're going to be cutting to today, you might need a shade 10 or a welding hood in some fashion. I do recommend wearing double face protection. Even if you do have your goggles and your respirator on, still wear that face shield, because this thing does throw some sparks, and if you're trying to pierce a hole, it could go right back in your face. So be safe out there. Now that we know a little bit more about safety and we're cautious, let's go over to this table and let's cut some sheet metal, some plate, do some CNC stuff, all kinds of fun stuff. Now we've got a chance to play with this machine. We're going to put it through its paces. We've got it hooked up, we've got the power on, and we've got to set up the gas right. So one thing that we have to consider is what pressure we're running. The Xtrafire is pretty sweet. We run 100 PSI to the machine, and depending on what process that we use and select, it'll actually regulate that pressure for us. Same thing with the post flow. Less amps we use, less post flow it's going to give us. The more amps we use, the more post flow it's going to give us. So it really does help us as far as taking care of the pressures and that post flow for the gas. And now as far as travel speeds, what do we set our amps to? Well, I'm just going to set this sucker for 105 and freaking send it. You can set your amperage depending on the material that you're using, thickness and alloy. However, if you can just judge your travel speed, you can go faster or slower based on your amperage. So we're going to crank her up to 105, and we're going to rip and tear through some 16 gauge, some 3/4 inch plate, and some 1.5 inch aluminum. Then we're going to take it over to some pipe, cut a saddle on a piece of pipe, and then hook it up to this CNC machine, see what else it's got. All right, so we're gonna try this 16 gauge out first. I'm gonna show you just how fast it can rip through this 16 gauge material. So before we get started, I got my big hunk of aluminum. I'm gonna use that as a fence or a guide so that I can place my torch right up there with that drag tip and I can just get to going on this piece of 16 gauge. It's gonna be super fast. 105 M's is more than enough to cut this 16 gauge material. We're gonna get to cutting now. Let's do it. Look at that cut, man. No dross whatsoever. Again, 105 amps, more than enough to cut this stuff. We flew through it, and that was as fast as I wanted to go. I bet it could have gone faster. So you can imagine if it's hooked up to some sort of automation, you would fly through something like 16 gauge with this piece of equipment. So next thing we're gonna do is move over to this 3/4 inch material. So we'll be able to do the same technique. We're gonna use this aluminum block, put a fence on the cut, and we're gonna have to slow things down. You're gonna notice your travel speed depending on that kerf width, which is the amount of material that we're removing between the metal, right? Whatever metal that plasma is blowing out, that's our kerf width. Obviously a faster travel speed is gonna be a more narrow kerf compared to a slower travel speed. You can also tell the direction if you start seeing your arc kind of blow back out and you're moving too quick. So we wanna try to get that perfect travel speed, and you'll notice a few things on the end of this torch to help you know if you're going the right travel speed for the amps that we're running. Let's cut some 3/4 inch.
It's the cut quality on the piece of plywood.
My bad, guys. These respirators are something else. I know y'all can't hear me. So check it out. We got a great cut quality on here. There's literally just very little dross on this 3/4 inch plate. Now that ain't nothing to sneeze at right there. We can easily get that off with a chisel. Got a little bit of a bevel on there. That was more user error. I didn't hold that torch quite straight up and down, but you could tell by that travel speed we slowed down. But man, that thing is still moving through this 3/4 inch plate, and it's real nice and smooth. So one thing we would just need to correct is my own personal torch angle. So we know they can cut some steel. Let's try out some really thick aluminum. Now I'm gonna have to go up as far as using my welding hood, because the arc, I'm gonna freehand this cut instead of the drag tip. The drag tip really conceals the arc. So now that that's the case, I'm gonna be running those high amps. I'm gonna be holding a little bit of a distance off so that I can see the cut. So I'm gonna use my welding hood to protect myself on this next 1.5 inch aluminum piece of bar stock. Now we know plasma cutters have the capability of cutting ferrous and non-ferrous metals. I've got a piece of 1.5 inch thick aluminum right here, and we're gonna arc axe it right in half. But that's not just the capabilities that this extra fire has. This 105 is able to pierce up to 1.5 inches, and it can come in from the side 2.25 inches. So this is still nothing compared to what this 105 can handle. So let's cut this thing up. Now I can't personally speak on my own, how straight I cut it, but it really cut straight through this piece of aluminum. It did really good, guys. Ooh. Cut right through that aluminum, guys, no problem. I didn't really put a good straight edge on it, so we just kind of free-handed it, but it made its way right through the aluminum. It may not look hot, that sucker is spicy. One thing we haven't talked about yet is actually piercing thicker material. Now this isn't too thick, it's only some Schedule 46 inch pipe. But when you're piercing it, you don't want to stand over top of it. You want to make sure you angle your torch at about a 45-degree angle to send all that molten metal way off the other direction and not back in your face. Once it pierces all the way through, you can straighten up. You really got to be worried about this when cutting a lot thicker metals. So make sure you're got that torch angled. Once it gets through, you can lean it down. Now we're gonna cut up this saddle, and this is for the B-roll. We got that saddle cut lickety split, man. That thing was quick. Didn't even run the max amperage there at about 85 amps. And you know, I can't complain with the plasma cutter's performance. I can't speak for myself. I had little shakes in there, but hey, nothing a little grinder can't fix. Now we've got the Xtrafire hooked up to the X-Track. We're gonna show you some of the CNC capabilities of this machine. Now I did say it comes CNC ready. All you need is just a simple pin, go through the back of the machine, and we're set. We're gonna cut out something very common in the industry, just a simple lift lug on some 3/4 inch plate. We're gonna cut and we're going to use the draw function. Now the draw function is basically like gouging, but drawing a pattern on a piece of material. And this is really handy in the industry, especially for really large parts, to where you can actually lay out a whole sheet of where things need to be cut out later on in the field or whatever have you. So it's got a nice cool draw function and the cut functions. We're gonna get it going on this CNC machine. So let's get rolling. I gotta hit this magic green button right here. Well, you can clearly tell that Xtrafire and the X-Track combo is pretty awesome, man. We got a nice smooth plasma cut there, nice good pierce, nice good hole. You know, if I'm looking at this dead on, I can see that there is a little bit of a chamfer to it, some angle, so we might need to adjust some of our travel speed settings, but overall this thing's cutting really slick on the plasma table. That's it, guys. That's the Xtrafire 105 HD from Thermacut. It's a straight boss, man. This thing, it's an arc axe, man. It's the closest thing to a lightsaber you're gonna get. Cut through whatever you want with a duty cycle to match it. It's gonna outwork you every time. Be sure to go download the Weld app, guys. We got tons of resources in there, tons of videos, marketplace, job boards. Great stuff, great community in there. Follow me, Austin Hargett, inside the Weld app. We'll see you there, or we'll see you on the next one.